Bismillahirrahmanirrahim. Dear students, grade 12, and this is lecture number 62. In the previous lecture, we completed the biochemistry. In the last lecture, we completed the biochemistry chapter number 21. According to the reduced syllabus issued by the federal board, you should have like this one also. So in the chapter number 22, industrial chemistry, you have the introduction, the branch of chemistry which applies physical and chemical procedures towards the transformation of natural raw materials and their derivatives to products that are benefit to humanity. Again, I am repeating. The branch of chemistry which applies physical and chemical procedures towards the transformation of natural raw materials and their derivatives to products that are benefits to humanity is called industrial chemistry. So many things we are going to produce in industries: food production, health and hygiene, shelter, protection, decoration, recreation, entertainment, clothing, cement, construction, many things we are going to manufacture in industry. So in the introduction, the chemical industry can be classified according to the type of main raw materials used and all type of principal products made. So we therefore have industrial inorganic chemical industries and industrial organic chemical industry. So we divide it into two: inorganic portion and organic portion. So industrial inorganic chemicals industries extract inorganic chemical substances made composite of the same and also synthesize inorganic chemicals. So these are the basic organic and inorganic chemicals. Heavy industrial organic chemicals industries, petroleum, fuels, polymers, pharmaceuticals and other synthetic materials, mostly from petroleum. Inorganic. Cement is inorganic. Petroleum is organic. So that's why we have the different. Light organic industrial produce especially chemicals which include pharmaceutical, dyes, pigments, paints, pesticides, soap, detergents, cosmetic and miscellaneous products. So dear students, this is an introduction about the industrial units divided into two portions: inorganic and organic. So different raw materials are going to be used in these type of units. So according to the reduced syllabus, then we start pesticides. Lecture number 62, chapter number 22, pesticides, and the class 12, industrial chemistry. So when we are talking about pesticide, this is page number 294 in your book, article 22.4. Pesticides may a chemical which is used by man to control pests in the agriculture. This agriculture use. In the agriculture industry, when we are going to be grow crops, different kinds of crops, we need crops, high yield of crops, before, I think 50 years back or 60 years, the farmer used natural fertilizer from the animals. So their production was less. They produced less quantity of the crops. But nowadays, the population of throughout the world is going to be increased and increase rapidly. So these techniques were old, they are insufficient. So that is why new techniques, modern techniques are going to be used to get a more production. So that is why we use different kinds of fertilizers and also other chemicals to increase the yield of the crop. So that's why pesticides are used to control the pests. The pests they are maybe small insects, maybe plant disease, maybe fungus, maybe weeds, maybe nematodes, maybe snails, maybe slugs, etc. and etc. So therefore, insecticides, fungicides, herbicides, etc. are all types of pesticides. Insecticides, fungicides, herbicides, they are all types of the pesticides. Now, types of pesticides. Types of pesticides. Number one, insecticides. Number one is insecticides. Insecticides are the chemicals used to control the insects, to kill, destroy small insects present in the field. Often the word insecticide is confused with the word pesticides. Sometimes there is a confusion in the insecticides and pesticides. It is, however, just one of many types of pesticides, and insecticides may kill the insect by touching. Maybe you touch and insect is going to be killed, or by swallowed, when it is going to be taken inside. It's more effective. Some insecticides kill both by touch and by swallowing. Insecticides called systematic may be absorbed, injected, or fed into plant or animal to be protected. Systemics, they call systemics. Maybe they absorb, maybe they inject, maybe they fed into the plant or animal to be protected. When the insect feeds on this plant or animal, it ingests the systemic chemical and kills it. So this is the insecticide. Then number two, medicides. Miticides. These miticides are acaricides. We also call acaricides. These are chemical to control the mites. Tiny insecticides spider-like animals and ticks. The chemicals usually must contact the mites or ticks to be effective. These animals are so numerous, many and small also. The great care must be used to completely cover the area on which the mites live. They are very high quantity, numerous, and also they are very small. That's why you have to be very careful about to destroy them. So miticides are very similar in action to the insecticides, and often the same pesticides kills both insects and mites. So this is the miticides number 3. Fungicides. Number 3, fungicides. Fungicides are chemicals used to control the fungi which causes molds, rots, and plant diseases. All fungicides work by coming in contact with the fungus because fungi do not swallow in the normal sense. So this is the fungicides. Number 4, herbicides. Herbicides are the chemicals used to control unwanted plants present in the field. Unwanted plants. These chemicals are a bit different from other pesticides because they are used to kill or slow the growth of unwanted some plants rather than protecting them to actual plants which we want to grow. Some herbicides kill every plant they contact, while others kill only certain plants. It is following types. There are 2 types. One is called non-selective herbicides. Non-selective, and other are selective herbicides. 2 kinds. Non-selective herbicides and selective herbicides. In the non-selective herbicides are toxic to all plants, all kinds of plants. Those are often used when no plants are wanted in an area. So we are not going to want any plant is open, then we put this chemical. Non-selective herbicides should be used for cleaning under guard rails or for total control of weeds in the industrial areas. Selective herbicides kill some plants with little or no injury to other plants. Usually, selective types will kill either broadleaves plants or grassy plants. Broadleaves plants or grassy plants. These are useful for the lawns, golf courses, or in areas with desirable trees are there. Some very selective herbicides may kill only certain plants in a group. For example, crabgrass killers on lawns. So this is about non-selective herbicides and selective herbicides. Number 5. Number 5 is Rodenticides. Rodenticides. Rodenticides are chemicals used to control rats, mice, bats, and other rodents. Chemicals which control other mammals, birds, and fishes are also grouped in this category by regulatory agencies. Most rodenticides are stomach poisons and are often applied as baits. Now, number six. Number six is nematides. Nematicides. In the nematicides, chemicals used to control nematodes. Nematodes are tiny hair-like worms, many of which live in the soil and feed the plant roots. So very few of these worms live above the ground. Usually soil fumigants are used to control nematodes in the soil. So number 6. Number 7. This is the molluscicides are chemicals used to control snail and slugs. Usually the chemicals must be eaten by the pest to work. Baits are often used to contract and kill snails, slugs in an area. Number 8, repellent. Repellent. A repellent is a pesticide that make a site of food unattractive, unattractive to a target pest. They are registered in the same way other pesticides and must be used according to the label which is given on the chemical. Insect repellents are available as aerosol and lotions and can be applied to the skin, clothing, or plant to repel biting and nuisance insects. These can be sprayed on the planted or nursery crops, ornamental planting, and also vineyards, vegetables, and seeds. So repelling deer, dogs, birds, also other can protect sites from the damage. So dear students, here there are the pesticides. Here there are 8 types of pesticides. Do the quick quizzes. They may ask the question from here, and must they ask from here. You have to solve all the 5 questions. So after 22.4, then you have to open 52.6 synthetic polymers. Synthetic polymers, page number 301. 301. The topic is Synthetic polymers. Synthetic polymers means we prepare these polymers in industry. So there are two given here. Synthetic polymers, two given: PVC and nylon. Polyvinyl chloride, PVC. Polymers are high molecular weight compounds whose structures are made up of large number of simple repeating units. We call them monomers. Just like I'm giving example, this is the ethene. This is the monomer, simple unit, small unit, and molecules of ethene according to the specific conditions, pressure, maybe temperature, oxygen small, less quantity, maybe the catalyst. So by applying the appropriate conditions, so we will get this the monomer. And we will get polymer. Double bond is removed. And this is the single unit of polymer we call polyethylene. Plastic we make this. Polyethylene bags, plastic we made. So you can see that valency of this carbon is not satisfied. So we don't know from where it starts. Huge, big N numbers. Still you are seeing in this side, right side also. So there the valency of this carbon is not satisfied. We don't know where it is going to be end. There are no starting, no end, huge, big numbers, large numbers, N numbers are called polymers. This is the first unit of the polymer I told you. And when you are mixing same types of monomers, these are called homopolymers. We call them homopolymers. So these are the homopolymers. So when the lower molecular mass, smaller units combine with each other in certain conditions according to requirement, you will get a large big molecule which has a very high molecular weight, high molecular mass, is called polymer, and the process is called polymerization. So there is a PVC, polyvinyl chloride. So there are two types of polymers. Number one, addition. Addition polymerization. This is the type of addition polymerization. You are adding many units, small units to get big one, large one. So this type is called addition polymerization. And next one is condensation. So condensation polymerization. So dear students, in the addition polymerization, this is the type of addition polymerization. So we have a polyvinyl chloride PVC is a type of addition polymerization. So dear students, PVC is prepared from the vinyl chloride. Vinyl chloride. You done the organic chemistry. I told you that two carbon atoms containing double covalent bond. If it has attached the functional group, so this is called vinyl and this is called chloride. If there is alcohol, we call vinyl alcohol. Vinyl chloride and molecules of vinyl chloride. This is the type of addition polymerization, same as this. So we are going to prepare a polyvinyl chloride PVC. So there is a conditions in polymerization. What are the conditions they apply? So they will give a huge big molecule which is called a polymer. There is a no end and there is a no starting. Double bond changes into a single bond. And the valency of this carbon is not satisfied. So this is called polyvinyl chloride PVC we use in the pipes. So it obtained by polymerization of vinyl chloride used in the manufacture of imitation of leather, floor covering, roofing material, and also graph-phones recorder or pipes plastic pipes are going to be met. Vinyl chloride is obtained. Now how the vinyl chloride is going to be obtained? It is going to be obtained from the acetylene. This is the acetylene, ethine or acetylene in presence of hydrogen chloride and mercury chloride as a catalyst. So on the one side you have to put the hydrogen with a double bond, on other side you have to put a chlorine to get a vinyl chloride. So there is second one is called nylon. Nylon is a type of condensation polymerization. Nylon preparation is a condensation polymerization. In condensation polymerization, when the monomers are going to be combined with each other, and there is an elimination, removal of small unit, which may be water, maybe ammonia, maybe methanol. So small molecules, small organic compound, inorganic, maybe water, maybe ammonia, maybe methanol are going to be eliminated, removed. That's why we call condensation. Just like we write condensed milk. What is to remove? Combination of monomers with the elimination of simple molecules like water, like methanol. So these are the two types of condensation polymers. Polyesters are polyamides. Polyesters and polyamides. Dear students, we are going to prepare nylon by using condensation, polymerization means when the simpler monomers compounds are going to be combined with each other with the removal of small molecules, water or methanol. So there are two types. One is called polyesters and polyamides. Polyesters and polyamides. So there is a formation of nylon 6,6. Nylon 6,6. I will tell you what is 6,6. Nylon 6,6 is the most important polyamides. Nylon 6,6 is a polyamide. It is obtained by heating adipic acid. Adipic acid. What is the adipic acid? The organic acid. 2-carboxylic acid functional group, and there are total 6 number of carbon atoms. So this is the 6th hexane dioic acid. That's why 6. That's hexane dioic acid, or we call adipic acid. So when this hexane dioic acid, this is the adipic acid, reacts with hexamethylamine. This is the amine group. And hexa, CH, again 6. That's why 6 amine. This is the hexamethylene diamine. Hexamethylene diamine. Hexane dioic acid. That's why we call 6,6. So when they are going to react at about 2000 degrees centigrade heat, then you will get the intermediate complex. This is the O is going to be removed, and you have CH2 and again CO, and hydrogen is removed. There the NH and the CH2 6, and then there is again NH. So this is the polymer here, and then there is a further reaction. So this is like this, we can write like this one. So this OH is going to be removed and hydrogen is going to be removed from here to make water. Again here, just continue. We don't know where this stops. So in the last, you will get CO, same group, NH2 then again CO, CO, then again NH, then CH2 6, and then NH, and molecule will form. This is called nylon 6 6. This is called nylon 6 6 because 6 carbon and 6 carbons are there. So dear students, nylon 66 was developed as a synthetic fiber for the production of stocking and other wearing appeal. It was introduced to the public at New York World Fair in 1939. It is used to make fibers for clothing and carpeting, filaments for fishing, lines and ropes, bristles for brushes, and molded objects such as gears and bearing can be prepared by using this. So students, these are the synthetic polymers. Again, I am going to introduce you that polymerization, the process in which the simple units combine to give a big molecule is called polymers. Two types of polymerization: addition polymerization and condensation polymerization. In addition polymerization, we have the example of ethene, and this is the vinyl chloride. So smaller units of many vinyl chloride, they polymerize to give big molecule. This is called polyvinyl chloride. This is the type of addition polymerization. In the condensation polymerization, step growth polymers. So when you are combine the smaller units with the removal of small units, water or methanol, to get the product, these are called condensation polymerizations. There are two types: polyesters and polyamides. So here only given here nylon. So this is nylon is a type of the polyamide compound. So we will get a nylon 6,6. So it is prepared from the adipic acid and also hexamethylene diamine to get the nylon 6,6. It's the fiber, and there are many uses for this one. There are again two types: thermoplastic and thermostatic plastic. Last topic, 2 lines. So thermoplastic polymer is the one which often on heating and becomes hard on cooling. The physical change is going to be take place, no permanent change, which can be used again. Thermostatic polymers, in one becomes hard on heating and it cannot be softened by heating. So there the decomposition taking place, permanent change takes place, permanent chemical change takes place. That's why this cannot be recovered again. So two types. So thank you very much. Here we completed the 22.6 synthetic polymers, PVC and nylon. Inshallah, in the next lecture we will start adhesives. Last topic, adhesives. Thank you very much.